What's up, First LEGO League challengers, and welcome back to the FLL video series playlist for robot design and strategy. Today, we're going to be covering the different parts of a robot, as well as the functions that they serve. Robots have software, electrical, and mechanical components. Software is the code that gives the instructions to the robot on what to do, like your brain. Electrical is the wiring that connects your brain to the other parts of the robot to send the signals, like the nerves in your body. Mechanical is the parts that you can see, touch, and move. The mechanical parts receive and follow the instructions that are sent through the wiring, similar to how your bones and muscles know to move. In FLL, the brick is the brain and contains the software. Motors, wheels, sensors, and attachments are the mechanical parts, and the wires that connect the brain to the mechanical components are the electrical parts. The main component of any FLL robot is the EV3 brick. The brick is essentially the brain of the robot. It is where all of the programs are stored and where you'll be running your programs from. When you look at the brick, the first thing that you will see is the screen. This is where all of your programs will be displayed and where you will find any information that you need about your robot. The arrows on the brick are what you will use to move around the display, and the center button is what you will use to select options on the display. The center button is what you will also use to turn on the robot after it has been shut down. The power button is what you will use in order to turn the robot off, and if you hold it down for more than a couple of seconds, it will ask you if you want to shut the robot down. The robot's battery is not the best, so you should try to keep it off until you need it on. The EV3 brick has 8 different ports. 4 of them are numbered and 4 of them are lettered. You will be plugging your motors into the lettered ports and your sensors into the numbered ports.
Large motors. These are some of the most fundamental parts of your robot. Without motors, your robot can't move, and you also can't make more complex attachments that also move. Large motors are most widely used for rotating the wheels that drive the robot across the mat. Large motors are also used for manipulating large attachments. In case you didn't know, attachments are additions to your robot that you will build to complete missions. There are also medium motors. Like the name says, these guys are smaller than large motors, but they still pack the rotational capability of their larger sized counterparts. These motors are better for attachments requiring more precision, as they make smaller movements. When using either of these motors for wheels, always try to put large and medium wheels on the large motors and small wheels on the medium motors. On the right is a simple robot we put together. Notice the placement of the large motors and their function. They are being used for the robot's wheels and also ensure stability as it is moving. Sensors are another part of your robot. While you don't need sensors to make a robot that works and accomplishes missions, sensors can make your job a lot easier. There are 4 sensors: the color, touch, gyro, and ultrasonic sensor. The most commonly used sensor out of all of them is the color sensor. It can be used for many things, most often being used for an align-to-align program. For this program, you can use some of the lines on the board to make your robot align to some of the missions, increasing your chance of successfully completing the mission. On the robot game field, there are large, thick black lines for which a line-following program can be used. 2 color sensors can also be used to make the robot perpendicular to a straight line. Gyro sensors are used to make more precise turns and can also tell you how much the robot turns down to the decimal. Next, touch sensors. When the button on these sensors is pressed, an action is done. However, in FLL, there is no real use for this sensor, as all of the programs will be selected from the brick, and touching the robot while it is moving results in a penalty. Lastly, the ultrasonic sensor. This sensor works like the echolocation of a bat. It sends out a high-pitched noise and waits for it to bounce off of an object in front of the sensor and come back to the bot. Once the sound wave comes back, it returns the distance from where the bot is to the object. This sensor is often used for missions where the bot must stop at a certain distance from an object. Here's an example of the color sensor. For reference, the color sensor is on the arm extending out past the front of the robot. We've programmed it to stop the robot when it senses the color red. The robot starts moving and stops when it touches the red line. Mission accomplished.
When building your robot, it is extremely important to choose your wheels carefully. The wheels generally come in 3 different sizes: large, medium, and small. Each size has its benefits and its drawbacks. Large wheels means that your robot is able to go a farther distance with each rotation of the wheel, but it also makes it harder to maneuver your robot. Smaller wheels make it much easier to precisely maneuver your robot, but it also means that you do not travel as far with each rotation. However, what is most important is that you get tires that are airless. This will allow for more reliable coating and mission runs. Wires are how your brick tells your motors what to do. It is extremely important that you wire your robot cleanly, as this ensures that it will be easier to repair your robot without wires getting in the way. The wires come in 3 different sizes: large, medium, and small. Only use the large wires when the motor or sensor is very far away from its port. Depending on how close the motor or sensor is to its port, you can either use the small or medium wires. You should wire your robot carefully, otherwise it can quickly turn into a messily wired robot. This can become a problem because things can get tangled in the wires, or it can be hard to trace back and troubleshoot problems with the robot.
Thanks for watching. Be sure to like and subscribe, as this helps other FLL challenge teams just like you find our videos so that they can get the support they need.